Are two eyes better than one? The researchers who conducted this experiment were Jasmine Vaughn and Kaylee Kyoto. Our main question is there a difference between using one eye, either the left or the right, or using both eyes? Specifically, is there a difference in the time it takes our individual eyes to process a visual stimulus and both eyes to process a visual stimulus? There are very few studies done on the difference between using one eye and two eyes in timing tasks. There was only one that we were able to find that compared one eye to both eyes. This topic is important because we use our eyes all day, every day. Not only that, but when we only use one eye, we take away about 25% of our visual field, and we also lose the ability to perceive depth and other visual features as well. Our hypothesis is two eyes will react to stimuli quicker than either the left or right eye individually. For our methods, our participants were both male and female, ages 18 to 24, and all the participants were psychology majors. Our experiment type was within subjects. We wanted to use within to find the difference in each person individually between using one eye and two eyes. We wanted to get rid of the possibility of having a bias of one participant being quicker at finding the visual stimulus and possibly having one group that has faster participants. We used a visual search task online where the participants were to answer if there was a green circle present or not. There were distractors in each trial that were either blue or green and either a circle or a square. Each run had 123 trials, and the participants did 3 runs. One run was with the right eye open only, second run was with the left eye open only, and the final run had both eyes open.
Okay. And here's the test we actually did. I'm going to do a little demonstration for you. Yes. So you can tell if it's absent or present. And of course, it starts off with a pop-out effect search. After about halfway through, it'll go to a conjunction search where there are green squares and blue circles everywhere, so you actually have to seriously look around and analyze each feature, which changes it. Yeah, so our experiment included both the pop-out and conjecture search tasks. Okay. In the end, our results were an average of the left eye being 939.1 milliseconds. Our participants averaged with using only the right eye to be 1122.3 milliseconds, and on average, everyone with using both eyes averaged at 823.3 milliseconds. So everyone averaged, about a second to react to something. And for calculation purposes, we averaged the averages of the left and the right eye results, which came out to be 1030.7 milliseconds. And we calculated the standard deviation for both eyes, which was 37.7525. And using that against the average of the individual eyes, our p-value came out to be 1.487 times 10 to the negative times the power of negative 5, or pretty much equaling 0, a very small p-value, which is good. Okay. And here is a graph of our reaction time. And as you can see, they are rather close, but with milliseconds and reaction times, even like 100 milliseconds is quite the difference. Okay. So because we had a very small p-value, we have evidence to reject the null hypothesis, which states that there is no difference between both eyes and an individual eye. So then we have evidence to say that we can reject the idea that that there is not a difference. It's double negatives. Once again, because that's how statistics work. Right. And in our test, there were a few confounding variables, such as the very small sample size. 9 is not very good for even a minimum sample size. And also, we didn't have a very diverse population. It was all undergraduates in the same classroom. Another issue was our repetitive stimuli. The test we showed you a moment ago only had, about a dozen different slides to show you. And with everyone being exposed to them 123 times per trial for 3 trials, that's over 300 times they're exposed to the same dozen slides. So it is possible that they could just simply memorize where the green circle is and then recognize a slide, then immediately go to the green circle and then know it's present instead of having to look through everything over and over again. And another issue is our units we used. One problem with that is because they are milliseconds, the units do become bigger, so the difference between our biggest and our smallest is about 200, which would cause the small p-value in the end. And we also have a biased sample because these all are psychology majors, so they probably could have known what we were doing it to begin with. And this is our citations page. And going back to introduction, saying how there are very few studies on 1 and 2 eyes. This was like the only one we could actually do that was purely based around that. Thank you for watching our presentation.